Okay, my name is Cesar Molins, and I'm the general manager or president, whichever way you want to call it, of AMIS, based in Barcelona, Spain.
So you're the co-chair of the Euro Presence Centre and a former EPMA president.
Mm-hmm.
So as a representative of the Presence Centre community and sector within the EPMA, can you tell us what the PM process or the benefits of PM components provide over other competing applications and processes?
Well, PM is a tremendous technology. PM has existed for many years already. And sometimes I think that even though PM Presence Center is not that well known by the wide public, the world, the Western world as we know it today, would not exist without PM. What are the advantages of PM? We can make very intricate geometric shapes with great precision, which is also needed for many things we use on a daily basis. It also has a very good usage of raw materials. That we could say is relatively important, only because after all, we could do the same thing using more material. But there are really shapes and geometries and precisions that would be unfeasible if it weren't for Presence Center technology. Then we have all the variety of materials, combinations of materials, even the fact that we can make materials which would otherwise be almost impossible to make. So in reality, PM Presence Center fills in a very important niche for mechanical and magnetic applications. So for people who are not technologists, are not knowledgeable about this technology, it is hard to imagine the crucial role of PM in today's world.
Super. So looking back over the last 30 years,
Mm-hmm.
I know you've been around a few
more.
Yeah. How have you seen the components that have been manufactured change over those years? Like what you've just said with the increased complexity, maybe different materials that have been added into the mix of.
We have seen all of that. We have seen a major increase of complexity. Materials have evolved. Also, another important thing, densities have increased, because one of the weak points of PM Presence Center is for high stress applications. We are not as strong as wrought materials, but even that has been closing the gap because higher and higher densities have been achieved. And also partial densification, surface densification, for example, that didn't exist 20 years ago. And I won't say they are commonplace today, but they are well established. So there has been a clear evolution on materials, on the machinery to use it also. Presses are more precise, they have better movements, more precise movements. Furnaces are way better than they used to be, which has allowed for better materials also. Or different alloys that were essentially unfeasible. I'm thinking now of the chrome alloys, which 25 years ago were almost unfeasible and today are relatively commonplace. So there has been a lot of evolution. The basic concept is still the same. It's powder, press, and center. Sure, but beyond that, inside of that, there have been numerous changes.
Excellent. So when we think about the future that you just started to allude to, is that where you see the Presence Center sector going, to adopt and to use these new alloys, these new materials within the existing process and streamline or make streamline the process even more?
That will happen for sure, but there are more things coming. For example, Presence Center is being used today to make components for fuel cells. Fuel cells are, somebody could say that they are already in the market today. Well, that is partially true. They are in the market, but they are not, how would I say, a competitively accepted solution. But will this happen? Almost for sure. And apparently, powder metallurgy Presence Center, by the way, will have a key role into that. So there are new sectors of market which are appearing with the changing of technologies, with the electrification, for example. Many people are concerned, what will the future of present scenery be if the cars ever go all electric? So first of all, I think it will take many years for the cars to go all electric, and we're not going to get into this discussion now because that's a long one. But even for the electrical applications, there are important applications that will go present center. And I continue to think that the world will need mechanical applications, high precision mechanical applications, for which present center will be a key player.
Excellent, excellent. And then finally, when we again look to the future, we think about obviously additive manufacturing. Do you see the synergy between the two of press and sinter additive to make components that may be unable to be made in any other way?
I think additive manufacturing will fill another gap, another niche market. It will be a complement. In a way like MIM. Our MIM and press and sinter competitors only in a very narrow range of parts. Normally the applications are distinctly different, and same thing will happen with additive manufacturing. Additive, which is making huge strides forward, has clear advantages and clear limitations also. The speed of production, the cost of raw material. Keep in mind that the cost of materials is one of the weak points of press and sinter also. We cannot make very large parts, first of all because of the size of the machines needed, but also because our raw material is so expensive. And the raw material for additive manufacturing is even more expensive. As of today, one order of magnitude, which is tremendous. Now the advantages on a geometric standpoint are huge too. What does it mean? It means that wherever you can achieve a shape and component characteristic with press and sinter, it will be very hard to find additive manufacturing to compete. But there are clearly shapes which will be absolutely unfeasible in press and sinter, which additive will facilitate. And we're going to see applications both in the traditional fields of today and completely new fields which are opening up, like medical, for example.